In this video, we are going to discuss how to use chain rule in differentiation. Chain rule is dy dx is equal to dy du multiplied by du dx. dy du multiplied by du dx. This is chain rule. This one, it means differentiate y. This one is differentiate y with respect to u, and this one is differentiate u with respect to x. Let us consider example number 8. Let's do this number 8 together. Now, number 8 is y is equal to 1 over x plus x raised to the power of 3. For me to expand this, it will take me a long time, as you can see. In order to prevent or to skip those steps of expanding, I can easily use u to represent 1 over x plus x. So I can say, let u be equal to 1 over x plus x. Now, if my u is that means this equation here, my y can then become u raised to the power of 3. And don't forget, my u itself is already equal to 1 over x plus x. Now, the next step is to differentiate y with respect to u and differentiate u with respect to x. So in that case, I will get my dy du and my du dx. Now let's go. My dy du, that means differentiate y with respect to u, it will be equal to 3u raised to the power of 2. Don't forget that this will come down and you subtract 1 from this. So next step is to get my du dx. Before my du dx, let me rearrange this my u. My u can be written as x raised to the power of -1, then plus x. Don't forget. So I can get my du dx now. My du dx will then be equal to this -1. It will come down. I will have -1 x minus 1 that was there before, then subtract 1 again according to the rule of differentiation, then plus 1. If I differentiate x, I will get 1. So let us transfer everything up there now. So let us go back to our dy du and du dx. In this case, right now, my dy du is already equal to 3u raised to the power of 2, as we have right here. And my du dx is also equal to -1. You can remove -1 in case they will give you the same outcome. -1 minus 1 is -2, then plus 1. This equation can also be written as minus x raised to the power of -2 plus 1. So I want to maintain -1, because of some students. If I remove -1, it might confuse them. So let us maintain that -1. So finally, go back to the formula. dy dx is equal to dy du multiplied by du dx. Then let us substitute. In this case now, dy dx is now equal to dy du. My dy du is this. That means 3u raised to power of 2 multiplied by my du dx. This is my du dx here, which is times minus 1x raised to power of minus 2 plus 1. So I can rewrite this to be dy dx is equal to 3u raised to power of 2 multiplied by 1 minus x raised to power of minus 2. Make sure you maintain the bracket. So finally, I can write this, I can raise this minus, I can remove this minus to become plus by bringing it down. That means my dy dx can also be equal to 3u raised to power 3u raised to power of 2, then multiplied by 1 minus 1 over x raised to power of 2. I will not stop here. Look at this u here. This u that is here, I have to return the original value of u back. If you go back to our equation, we use here that let u be equal to 1 over x plus x. So that means that my final answer will be dy dx is equal to 3. I will put u there, bracket 1 over x, then plus x raised to power of 2, then multiply by 1 minus 1 over x raised to power of 2. That is my dy dx. This is how to use chain rule. Now let us see example number 7. You can see that the exponent there is a fraction. Now let us see example number 7 quickly. Now, for number 7, don't forget your formula for the chain rule. So let me repeat that again quickly. Chain rule is dy dx is equal to dy du multiplied by du dx. Now, for number 7, I have y is equal to x raised to power of 2 minus 1 exponent of 3 over 2. You can see that it is not possible for me to get rid of this particular bracket because I have to consider this exponent of 1 over 2. In this case, I will use u to represent what is inside this bracket. So I can say let u be equal to x squared minus 1. So that means my equation y can easily be equal to u raised to power of 3 over 2. Now I can then, let me copy out both of them. If my u, if my y is equal to u raised to power of 3 over 2 and my u is equal to x squared minus 1. Now I can get my dy du. Differentiate y with respect to u. This one will be equal to 3 over 2 will come down, that will be 3 over 2u, then 3 over 2 minus 1. I can also get my du dx. My du dx, that differentiates u with respect to x, that will be equal to 2x. If you differentiate any constant, it will give you 0. So in this case, I already have my dy du that it is equal to 3 over 2u, 3 over 2 minus 1. You give me 1 over 2. That is 1 over 2. And then also, I have my du dx, which is also already equal to 2x. So right now, I can apply the formula, which says that dy dx is equal to dy du multiplied by du dx. Now let us now substitute. So dy dx will now be equal to dy du. Dy du is this. This is my dy du right here. Let us substitute that. That will be 3 over 2u raised to the power of 1 over 2, then multiply by du dx. My du dx is what I have here, which is 2x. Now, in this case, I have coefficient that is 3 over 2 right here. Coefficient here is 3 over 2. Coefficient here is 2. So 3 over 2 multiplied by 2 will give me 3. So in this case, I am now going to have 3u raised to the power of 1 over 2, then multiplied by x. Because this 2 has already multiplied this 3 over 2. So to give me 3. Now return your u back. Don't forget that this is my u right here. This is original value for u. Return u back. This equation will then become dy dx is equal to 3 bracket u, which is x raised to the power of 2 minus 1, close the bracket. Everything here raised to the power of 1 over 2, then multiplied by x. So finally, dy dx can now be equal to 3x, that is this 3 multiplied by this x, give me 3x, bracket x raised to the power of 2 minus 1, then raised to the power of 2, 1 over 2. So you can stop here, which is fine. We can also rewrite this by saying that dy dx is equal to 3x, then square root of x squared minus 1. So this square root is representing 1 over 2. So this is the final answer. This is how to use chain rule. If you find any part difficult, please kindly contact us and we are ready to explain. Follow us in case you need more information about this lesson. Thank you very much. Enjoy your day.